Hello everyone, today I'm going to be talking about the D programming language. So first off, what is D? Well, it's a relatively new programming language. It was first started development in 2001 and by a company called Digital Mars that used to make C and C++ compilers. And it's grown through the years, and it's aimed at being a systems and applications programming language. So that means you can write both native application code as well as operating systems in D. It's statically typed, and it has like C-like syntax. So if you're familiar with C, C++, or Java, then you'll feel right at home. It has an optional garbage collector, so that means you can use pointers, or you can't, or you don't if you don't want to. It also has some nice, cool things like type inference and all that jazz. So what makes D different? Well, D is designed at being a practical language that has sort of the power and capabilities of language like C++, but has a more modern language design, so it doesn't have the cruft of being built on top of C, like C++ was. So there's no backwards compatibility concerns, and it's aimed at being a more intermediate to advanced programming language. It's more intended to be sort of your second programming language once you know how to program in general. And as such, they wanted to support a bunch of different programming styles. So you can do things like C-like function and data programming. You can do object-oriented programming like in Java and C++. You can do crazy meta template programming if you want to, as well as functional style programming with a few special keywords. So what does it look like? Well, it looks something like this. This is an example program I created that just goes through a file and counts the occurrences of each word that it sees. And if you look, it looks a lot like C, C++, or Java. And as such, in the next few slides, I'll be going over just a few features and comparing it to those languages. So first up, D versus the C preprocessor. This one's an easy one. So first up, there's the alias keyword. Now this is D's response to the C preprocessor's defined macros. And essentially they are syntax aware, find and replace. Unlike the C preprocessor, which does a dumb copy-paste, the alias command will the compiler will actually understand what's going on underneath. So here you can see C processor code as well as D code that does the same thing. Or when you're working with an API that has two different versions of a function based on whether you want to use Unicode or not. In the C preprocessor, you'd use these defines and this the get value to whatever function you wanted. In D, there's a cool version keyword which pulls in information about the runtime and build environment, so that will tell you if you have Unicode. And then you see these alias blocks, which will do a significant replace in the rest of the program. D also has modules, so they're Java-like packages and modules, unlike the C preprocessor, which uses pound includes and header guards. So that means you don't have to, when the compiler runs, it doesn't have to copy and paste the entire file every time it sees a pound include. It does it much like Java, where it just keeps track based on the file name and the folder names. You can specify, as you see here, there's a module command you can specify this file is part of this module. By default, it just chooses the current file and directory name as your module. And you can also do static imports. So if you really do need to literally copy and paste a file in, like if you're doing like operating systems programming and you have some binary data that just needs to be put in the file, you can do a static import and that will just show up. So, moving on, compare it to C. So D has a lot of your standard primitive built-in types. It has things, like int, long, double, byte, all of those pretty standard types. But it doesn't have an unsigned keyword. It uses uint, ulong, etc., instead. So your type names are a little bit shorter. But the really nice thing is that D guarantees that these types will have the same size on every platform you use. So that means if you're going from some strange ARM board to an x86 computer, int will always be 32 bits, no questions asked. You don't have to include a types.h and redefine things. That's just standard. Pointers are also in D, although they are a little bit discouraged. So by default, pointers are disabled. You have to explicitly mark files. You can mark files as either safe, trusted, or system. And that means if it's a safe file, it doesn't use any pointers at all. If it's a system file, you can use pointers and pointer arithmetic as much as you want. And a trusted file is one that includes system files. So it's sort of like an API layer that safe programs can call trusted code, and trusted code can call system code. It's like a buffer for your API. So when you're using the safe mode, which is standard, you will be using a built-in garbage collector. And you don't have to worry about memory management. And here you can see just an example low-level OS pointer magic. So D also has structs, like in C, but they're a little bit more advanced. So, like C, they're just a collection of primitives and built-in primitives and other structs, but it allows for additional methods. They really end up feeling almost more class-like than C structs do, in that you can have things like constructors, you can have entire methods that set properties of a struct. So what that means is you can do, like the primitive types have a size of property. So you can do int.sizeof, and that'll give you the size of an int in bytes. But you can define your own. You can have, I don't know, you could have, like you could add your own, if this didn't already exist, you could add a max value. You could define a function, say this is a property, it's called max value, and then anyone on your type say, property, could say type name.maxValue. You have that property. So they're almost like static level types. So yeah, you can also see the constructors and destructors, but they also have operator overloading if you want. So that means the goal of these structs was the people making D wanted it to be possible for you as a programmer to implement the types that they have in their standard library by yourself. That sort of arrays and hash tables are not magic. You could do it yourself if you really wanted to. So you can have an operator that has an index operator, so you can do the array style index. So on my type, when you index it by an int, you can decide what happens there. So these are really powerful compared to a basic C struct. So D also has built-in static and dynamic arrays. So that means you can declare a static array just by putting in the size while you're writing it, or if you don't know, you can just leave the size out and you have a dynamic array. They have things like slicing operators, which is this here. You can say a range of values. What's really cool is that's actually usable on both sides of the expression. So you can actually say dynamic 5 through 8 equals fixed 0 through 3, and it just does a raw copy of all those values. And it also has associative arrays, so things like a hash map. So here you have a dictionary, and all you do is you put the type that you're indexing by inside the array brackets. So you say int index by string, that's my dictionary, and then you can go to the hello entry and increment it. Something I didn't mention last slide on the structs, all types by default have a default value. They are initialized and guaranteed to be that value. So you can see here, like if I didn't have this constructor, I could keep this color, these color fields just like this, and by default, these would all be set to 0 because bytes and ints are always default initialized to 0. Okay, So, D versus C++ and Java. So that means object-oriented programming. So D also has classes and interfaces. It's very much more like the Java side in terms of class hierarchies and things like that and how you use object-oriented stuff. But it also has things like operator overloading that you get in C++. So here's an example, little mini class, and you'll see it looks pretty familiar. You can do this is extending another class. You can have your field variables, a constructor, various methods. And another thing is you can actually simulate multiple inheritance if you really want to via some crazy magic called subtyping. I won't get into it because it's a little more advanced, but it allows D to have single inheritance, which means there's always a strict order of the classes. But if you have two objects and you need to extend them, you can choose a primary class and a secondary class, and set it up so that you get the functionality of both, provided there isn't conflicting methods and things like that. D also supports templates, and they're a lot more like C++ style templates. It uses a different syntax, so it uses an exclamation point and parens with the type. And that's so, if you've ever used C++ or Java, you know they use the angle brackets. The problem with angle brackets is it makes the program that parses the code a lot more difficult. So D is a context-free grammar language, if you know what that means. So that means there's no ambiguity. In C++, if you have nested templates, you'll have two angle brackets right next to each other, and when you're parsing C++, you don't know if that's two templates nested or if that's a shift operator. And so in D, they tried to avoid that, so they use the exclamation point. One thing that's really, really, really cool about D is they have these things called traits, and you can define your own and everything, and what they allow for is an insane amount of control in how your templates behave. So in here, this is a rectangle template, and it has a top, width, and height. But what's cool is we've said this is a rectangle where the type is anything that's numeric. So you can make a rectangle of floats, of ints, of any numeric type, and it will instantiate that. And you can do some really crazy things with that, with this sort of if statement here. You can do things like saying, I want all types where if I run this code, it compiles correctly. So you can verify that a certain type has certain methods, or it has certain properties, and it can get very fine-grained. And D has some very nice sort of automatic casting. It has very strict rules, and it's very sensible how it does casting. So here you can see I have a contains method that takes in two of the same type and tells it if that point is contained inside the rectangle. You can use other, if you made this class with a int, like I did down here, so we're using the alias, and here you can see the exclamation point int. If you use an int rect, you can still pass in floats here, and it will do the right thing in the conversions that you need. So now this is another really cool feature. It's called scope guards. Scope guards are an alternative to try-catch blocks. D also has try-catch blocks, but it has this, which can really clean up your code if you use them correctly. So what it does is it denotes code that should run at the end of the current scope. So if you're in a method and you want to guarantee when you open a file that it closes, you can put right underneath it a scope exit command that says file.close. And then from there on in the file, if within that method something happens, either it returns or there's an exception was thrown, the file.close will always run. And so that avoids a situation where you have, if you've ever worked with file.io in Java, you'll know you can get really crazy nested try-catch blocks. So this way, you just put, I opened a file, I opened another file, and you just block up the scope blocks, and when it's, if an exception is thrown, it will replay these in reverse order. So it'll say, oh, I saw this one last, so I'm going to run that, I'm going to run this, run this, run this, run this. And it really helps a lot in the code flow. So you can do that on exit, you can do it only if the method returned successfully, or only if the method returned on a failure. So that's some of the comparisons, some of the cool features that D adds in addition. Here are a few additional features that I thought were worth mentioning. First up, D has a pretty cool concurrency model. By default, D has decided that data is not shared. So unlike Java, in Java, implicitly, in a class, all your variables are shared between any threads that are running in that class. In D, it's the opposite. By default, every sharing is not allowed, and you have to explicitly mark variables with a shared keyword to say, I'm expecting this to be a shared variable. D has traditional locks and threads, so you can do that if you want, but the really cool and new way to do it is to do message passing between different threads. So if any of you have taken concurrent, this is the actor model where you have two different threads and they send messages that can't change. They send immutable messages between each other, and there are send and receive blocks. I think, yes, I have an example of one here. If you haven't taken concurrent before, this might be all a little foreign, but essentially what's going on here is there's this foo method up here, which is being run as a separate thread. And then what happens is when you spawn the thread, you get a thread ID, and then the main loop can send that thread through its thread ID. It can send it messages of, so here it's sending a bunch of ints, a float, and then the string hello, and then it's sending the thread ID of the thread. So what happens in the separate thread is it has this cool receive method that actually does type pattern matching. So it says, hey, I got an int this time, so I'm going to run this code here. Or I got the thread ID, so that means I got the thread ID of the sender, and I'm going to stop running and send a response. And then they also have a catch-all called variant, which catches any other types that you haven't matched. So you can do error handling or something like that. And it's a pretty powerful way to do it. D also has function literals and delegates. So function literals are like function pointers. They're pretty simple. You can see one here where you can say, if you call your method function, and you can put anything in that and sign it into a variable. And then you can call function later by calling f and some variable. So in here you see it would check if it's less than 0. Delegates, on the other hand, are more like closures where they package in the context of the call. So you couldn't make a function pointer for this one down here because it's referring to a variable that's not inside the function. So if you want to do that, you have to make a delegate that says, whoever calls me can, I can use the current scope and say, oh, it's anything less than 5. This was done because there's a big performance difference between those two. But what's cool with D's type inference, you can see how we're using auto here, it just figures out what the type is. You can actually omit function and delegate, and the D compiler will know, oh hey, this isn't using any extra scope, I can make this a function and be more efficient. Oh hey, this one's a delegate because I'm using extra scope, and you don't have to know, you don't have to put in those keywords if you don't want to. D also has a built-in unit testing framework. So in any piece of code, you can write a unit test block, like one of these. And essentially, on the compiler, you can pass in a flag, and it will run all your tests. So here, this is just the basic class that has an add method that returns 2 numbers. And you can make a unit test block and run some assertions to make sure everything works. And then when you go to the command line, you can run this, and check your entire code base. And there's a lot more. I mean a lot more. Like more than I could go into in a couple hours. There's things like static conditionals where you have, you can compile things you can run code at compile time. So say you have a big data table you want to fill up, you can write a method that generates the data and dumps it into the data table with a static if. There's things like in-out parameters that allow you to do references, and things like strings for Unicode, and just a whole bunch of things, mix-ins, nested functions. So if you, but unfortunately currently there's a couple of shortcomings I should tell you about. There are very few libraries for D right now. So some of the libraries were even written for the first version of the language, D1, which D's been in development since 2001, but around, I think maybe 2006 or something like that, they ditched everything in the language and said we're starting from scratch because they had learned a lot about how everything was coming together, and they wanted to make sure their code base was a little more cohesive. So, but the nice thing is C libraries can be used without modification within D. You can just do a simple bind to the C function calls, and so any C-based library is easily used. So for example, I started writing a little game framework thing that uses OpenGL, so that's a C-based API. So you can use D to work with OpenGL and SDL. It does not quite work with C++ bind compatibility, because that would have required the writers of the decompiler to essentially write an entire C++ compiler as well. They didn't really feel like doing that. So you can do, if you really want to put the effort into it, you can like take a C++ API, convert it to C, and then import it through D. But there are some people who have done that, but it's a little bit more work. The language is still in active development, including the compiler. The language itself is pretty stable at this point. There's not a whole lot of changes per se, but the compiler still has bugs. I've run into a couple. It's not uncommon. But the good thing is the language is evolving. It's gaining popularity. There's going to be, they just kickstarted a conference that they'll be holding this year, so they've got their own conference now. And if you want to learn D, the first place to look is the D-Lang website. It has a list of the features, including all of the millions I didn't get to today, as well as some example code. You can also download the compiler there and try things out. If you really want to get into D, you should really pick up the D programming language book by Andrei Alexandrescu. It really goes into a lot of detail, and once you read it, you will know everything there is to know about D. It's a pretty comprehensive book. So with that, are there any questions? Yes?
How did you feel the use of being able to use structs and classes? Like, did they clash at all, or like have trouble choosing which way you should go with it? Seems like it would be an interesting feature.
I found it to be very helpful. I liked making the distinction between something that's purely a data type versus something that has functionality. So in the game framework I was working, I wanted you saw that rectangle class. I wanted that to be a struct because all it is four ints or floats or whatever. It's four numbers and ways to, and you just want some convenient things to mess with those numbers. Like, hey, I want to add this point so that it shifts the whole thing. And being able to make that distinction, I found was pretty helpful. Yes?
Do you have like a web framework, a web server available for it yet, or not yet?
I'm not sure. Yeah, there's like, if so, it's probably not a very good one at this point. All the libraries I've seen, most of them are pretty young.
And then, is it, in terms of, so like, if you were to compare like Java's like parallel collection library or concurrent collection library to like D's, would you say, like, does D have a mature like collections library that's like for real world use yet? Or not?
Yes, it has. It's got. I'm pretty sure it's got a pretty good collections framework, and the standard library has grown a lot lately. In the early versions of D1, that was the major complaint, was the standard library was terrible. So you may find, if you look for D, you may find on the internet a reference to the Tango project, which was essentially a very Java-style collections framework, or just standard library that people made for the first version of D. Nowadays it's not really relevant. The standard library is pretty good. So far anything I've needed to do I've found in there. But I haven't done quite a direct comparison, so maybe if you're getting to some more advanced features you may find there's a couple things missing. Yes.
So I have a question. You said you could drop off the function declarations in some places and you would just know that it was a function. So are functions implicit when you have parentheses and then a bracket or something?
Right, yeah, so it notices, like, you can even drop, if you don't have any parameters, you can even just use like curly braces in this, like the statement. So all the decompiler needs is like the bare minimum of information to figure it out, which
So does that mean then that like with like while loops and stuff like that, I could throw a function at them instead of a code block, or does it actually still have to be a inline code block?
yeah, you should be able to throw a function at those. And the other thing D supports is nested functions, so if you want to make a local function that you're just calling a bunch of times in one area, you can do that as well. Yes.
So I think having the unit test right next to your code is a really cool idea, but it seems like it could get pretty unwieldy pretty fast. You had the chance to use that in a system where that does that?
I haven't used it in anything too big, but I have the same worry you do, where that could be maybe not the best. I'm pretty sure you can still make a whole separate D file that just has unit tests, but certainly for quick programs it's very helpful, but I could see that getting cumbersome in a large project.
And then so for each test that you want to run, would it get its own unit test block, or would you have multiple tests within that block?
You can have multiple tests within the unit test scope. Yes.
Did you show an example of using traits? I must have missed that.
Traits. So it was. You can see it inside the template that I have here. So this is numeric. That's a trait that you can use. So that will take a type and tell you, is it numeric, and you can run a whole bunch of these things. So someone in some example code I saw had a thing that said, is the SSE extension supported inside of this right now? And if the target architecture had those extensions, it would compile those in. So you can use them in if blocks or anywhere, but it's really powerful when you use them with the templates.
Could you write your own traits?
Yes, you can. I don't exactly know the syntax for it, but that is possible.
So I noticed that the trait has an exclamation point over it, just like after it, just like a template does. So does an exclamation point indicate anything that's type neutral, essentially?
Maybe, yeah, that caught me by surprise as well. I'd have to go back and look, but that might be the case. Yes.
Is it fast yet?
Is it fast? It is pretty fast. It's not like the fastest, but being a native compiled language, it's one of its goals.
So would you say like it's already faster than like a warm JVM or not yet? Or
Yeah, it's hard to say.
Has
Yeah,
the
you'd have
potential
to
get
like.
there?
It'd be interesting to see if someone did those kind of comparisons. Yes.
So classes have inheritance, obviously. Do structs have inheritance? Or is it like the implicit inheritance like C?
I can't remember. My first instinct is to say no, but I'm not sure.
Okay.
Anyone else?
So would you say that there's a lack in popularity for D because it's just not fully developed yet, or do you think it's like not very popular at the moment, or what's the current standing of D?
It's gaining popularity. Over the last few months, I see more and more posts about it. I think, from what I can tell, there was a pretty active community that sort of died out when they did the D1 to D2 switch over. But think D's better off for it. But it's been growing. There's sections on Stack Overflow for it, and you'll get prompt answers to your questions there. And now there's this conference that was just funded, and I see more people posting on Reddit about it all the time. So it's picking up, but I get the impression like before now, a lot of people sort of saw D and said, oh, that's pretty cool, but maybe done the same thing. I sort of like, oh, there's no libraries. What am I going to do here? But that sort of stuff, the libraries are growing, but they're still pretty thin. But I wouldn't be surprised to see D grow quite a bit in the next year or two. Well, thank you for having me.